Introduction to reduction and oxidation reactions, also known as redox reactions. Reduction historically meant that we'd take something like a iron ore and we'd burn it in a big fire, and some of the carbon monoxide from the fire would reduce the iron ore. We'd start with a big pile of it and we'd end up with a smaller amount of iron, and so it was referred to as a reduction. In this case, iron 3 oxide is being reduced into iron ore by the thing, so the oxidizing agent in this case is carbon monoxide. And if this isn't going to convince you to learn how to program, nothing will. A traditional steel mill essentially can make 50 tons of steel and employs 1,000 people. A modern steel mill can make 50,000 tons of steel and employs 14 people. So learn how to program. Oxidation. This historically has meant reacting with oxygen. We no longer use it as necessarily that oxygen is there, but things like combustion and corrosion were considered oxidation reactions, where you have something that is being oxidized by the oxidizing agent, in this case oxygen, but it does not have to be oxygen to be an oxidizing agent, but historically that's where it's coming from. So now we are referring to reduction and oxidation, and it's all about the electron transfer. So a reduction reaction is going to involve an oxidation, which is the loss of electrons, and it will involve a reduction, which is the gain of electrons. And this is the fundamental definition of a reduction and an oxidation. Oxidation is loss, reduction is gain. And an easy way to remember that is to think of oxidation is loss as oil, reduction is gain, rig. And so that'll help you remember it. If you hear something like Leo Gerd, doesn't work as well, oil rig is the way to go. Realize that the total electrons lost must equal the electrons gained. And so these electrons are moving from one thing that is losing them to something that is gaining them. That's a redox reaction. So for example, we have a reaction here with magnesium and hydrochloric acid. If we were to break this into half reactions, we'd be able to see who is losing electrons and who is gaining electrons. But you need to make sure you have a full understanding as to what it means to be an ionic substance that is aqueous. Because remember, if this HCl, if it is aqueous, it is not molecules of HCl stuck together. There are hydrogen ions that are surrounded by water, and there are chloride ions that are surrounded by water. They are not together. We write them as if they are, but they are not. Same thing with aqueous magnesium chloride. There are magnesium ions that are surrounded by water, and there are two chloride ions that are surrounded by water. They are nowhere near each other. They are in the water, and that's what it means to be an aqueous ionic substance. So if we were to write the half reactions, we'd write what's happening to magnesium and what's happening to the hydrogen, because this chloride, if it starts out as a chloride ion and ends up as a chloride ion, it really hasn't done anything. So think of what's happening in terms of the atoms and the ions. Are atoms becoming ions? Are ions becoming atoms? Or it could actually be one type of ion with one charge becoming another charge, another ion with a different charge. So say a 2+ to a 3+. That would also be a change in electrons. So essentially, redox reactions are all about where the electrons go and who's gaining and who's losing. So once we figure that out, we think about it, we can actually write out what is happening, and we're going to break it up into two parts. So think of the magnesium as doing its thing and the hydrogen as doing its thing. So we're looking at the magnesium and the hydrogen, and we write those out as half reactions, and we see the electrons being lost and gained. So to start off with, if we look at magnesium here, it has, that's a magnesium atom, it has all of its electrons. And over here, it's a magnesium ion with a 2+ charge. The only way it can go from a magnesium atom to a magnesium positively charged ion is if it loses electrons. And remember, oxidation is loss. And then if you look at hydrogen here, it starts out as an ion because it's part of that. It's that hydrogen ion in the acid, and in the water as an acid. And it becomes a hydrogen gas molecule, which consists of two hydrogen atoms bonded to each other, each with their full complement of electrons. So this hydrogen ion must have gained an electron in order to take part in this molecule over here called hydrogen gas. And so reduction is the gain of electrons. So magnesium is being oxidized, hydrogen is being reduced. So if we write those out as reactions, and we say, okay, well, here's the magnesium here. It's starting out as a solid magnesium. It's becoming a 2+ ion. And in order to do that, it must let go. So think of it, this had the electrons here, and here it let go of them. So they actually became separated from each other. The 2 electrons came off of the magnesium, leaving it as an ion. And now these 2 electrons are free to move somewhere else. And the hydrogens, we need 2 of them to make our hydrogen gas molecule. So this 2 hydrogen together as a molecule, they would have started as hydrogen ions that picked up. So these 2 came together and formed this hydrogen gas molecule. So we have our 2 half reactions, our oxidation, which is the loss of electrons. So you see it over here on the right hand side. It's letting go and producing those electrons. And then we have the reduction, which is the gain of electrons, and we have it over here on the left going into the reaction, and that is the hydrogen ions gaining that, and that is our reduction half reaction. So we have our 2 half reactions. The 2 of them together are referred to as a redox reaction. So again, oxidation and reduction reactions occur simultaneously. So if you have 2 things, one of them is essentially going to be transferring electrons to the other, and so we can think of, in this case, A is losing its electrons, so it's becoming positively charged, and B here, which started out as neutral, it is now becoming negatively charged because it has picked up an electron from A. So the electron has moved from A to B, and now we have them here having gone through that transfer of electrons.